Good morning, everyone, and welcome back to another beautiful day in our classroom. One thing that has been requested from a lot of students is that they would like a video to go back and review standard algorithm for multiplication that explains why you bring down the zeros. I've been meeting with a lot of small groups about this lately, and a lot of students were really confused. So we're just going to go over this one more time to make sure that if you need the resource, you've got the video. So let's get going. Our first problem that we're going to work this morning is 59 times 86. Now, in order to understand why we bring down the zeros down here, we're going to need to look at our partial products. So I'm going to draw my partial product box. My first factor does not change, it stays 59. But my second factor needs to be broken up into its values. The value of the 8 is 80, the value of the 6 is 6. So I'm going to solve this partial product box first before we move on to the standard algorithm. Now 59 times 6 is pretty straightforward. We can solve that. We know how to do that. 9 times 6 is 54. 5 times 6 is 30, plus 5 is 35. So 59 times 6 is 354. Now when we get to the 59 times 80, this is where I really want students to think about the strategies that we use to multiply by tens, hundreds, thousands. Because this 0, we're just going to go ahead and bring down into our answer. So that this way, when we work the problem, we can just multiply 59 times 8. 9 times 8 is 72. 5 times 8 is 40, plus 7 is 47. So 59 times 8 is 472, but 59 times 80 would be 4,720. Pardon the cough. Now, this is going to come into play here in just a minute. Now that we've completed our partial products, now we're going to come back and we're going to continue looking at the standard algorithm. 9 times 6 is 54. 5 times 6 is 30, plus 5 is 35. Wait a minute, this looks really familiar. When we multiplied 59 times 6, we got the same thing. So this first row is simply a partial product that, hey, we've already proven works. Now is when we've got to talk about that pesky 0, because before we move on and multiply, we've got to bring a 0 down. And you'll see why here in just a second. We're done with the 6. We do not need that carryover. 9 times 8 is 72. 5 times 8 is 40, plus 7 is 47. And once again, doesn't this look familiar? Because 59 times 8 was 472. We just added the 0 on the end so that we're showing that 4,720 is also the product of 59 times 80. And now all we need to do is add. So our final product is 5,074. Right? So with 2-digit by 2-digit, that 1 0 is not a problem. But everybody always looks at me and says, well, Ms. Pike, then what's up with when you're multiplying more digits together, all of a sudden there are all of these zeros running around? It makes no sense whatsoever. Take a deep breath. We're going to work it out. Our next problem is 596 times 834. Just like we did up here, we need to set up a partial product box. The 596, our first factor, is not going to change. Our second factor is going to be broken up into its values. The 8 has a value of 800. The 3 has a value of 30. The 4 has a value of 4. 596 times 4, that's pretty simple. 6 times 4 is 24. 9 times 4 is 36 plus 2 is 38. 5 times 4 is 20 plus 3 is 23. So 596 times 4 is 2,384. Now once again, we're coming to those pesky little zeros. I'm going to go ahead and just transfer this 0 into my answer so that I can solve 596 times 3. 6 times 3 is 18. 9 times 3 is 27 plus 1 is 28. 5 times 3 is 15 plus 2 is 17. And then we just transfer our product so that we know 596 times 30 is 17,880. And yet again, we've got 2 more pesky little zeros that we're just going to go ahead and transfer into our answer before we begin. That way we can multiply 596 times 8 and make this a lot simpler. 6 times 8 is 48. 9 times 8 is 72 plus 4 is 76. 5 times 8 is 40 plus 7 is 47. We transfer our product. So 596 times 8 was 4,768, but 596 times 800 is 476,800. Now let's see how this connects to our standard algorithm. 6 times 4 is 24. 9 times 4 is 36 plus 2 is 38. 5 times 4 is 20 plus 3 is 23. Once again, this first row equals 596 times 4. Making these connections. We're done with the 4. We do not need to worry about those regroupings. So I'm going to cross them out. And yet again, now that we're multiplying by a number in the tens place, we need to add that 0 so that our numbers start falling starting in the tens place. 6 times 3 is 18. 9 times 3 is 27 plus 1 is 28. 5 times 3 is 15 plus 2 is 17. And once again, 596 times 30. This looks familiar. Now we're multiplying by a number in the hundreds place, so we need to add 2 zeros so that our numbers start lining up properly. We're done with the 3. We're done with what we regrouped. 6 times 8 is 48. 9 times 8 is 72, plus 4 is 76. 5 times 8 is 40, plus 7 is 47. And once again, this equals 596 times 800. 4, 16, 20, it's 13, plus 4 is 17, 9, and 4. For a final product of 497,064. So when students are working on standard algorithm of multiplication and they're confused about why these zeros get put here, remind them to draw this partial product box because this explains exactly why. All right, thank you guys for joining me. Have a great day.